Okay, thanks everyone for coming. This is the final session for construction and talk about leaving the best till last. This is a great story to end the construction track on. Just a little bit of background, and this next story you're going to hear is about being at the right place at the right time. I happened to be in Perth about 2.5 years ago with my technical account manager, and was at a meeting at Worley Parsons, who this story comes from. Wasn't meeting the two gentlemen that are here today. I was meeting someone else, but I did drop in to say hello to Tom Flanagan while I was there. Daniel Callan happened to be in his office at the time, and we just introduced ourselves to each other, and just said, what are you doing here? And they started to talk about this project. I was with my technical account manager, Johnny Tullock, who's up the back, and we started talking about some technology that we had, and as they say, the rest is history. So I'd like to introduce you to Daniel Callan. He's the lead planner for Worley Parsons, and Thomas Flanagan, who is you've got a long title, Tom, Global Construction and Completion Systems Manager, Worley Parsons, to talk to you about improving construction performance of oil and gas, and in particular the Hebron project. So thank you, Tom.
Okay. Is the how we going? Can we see that? So Worley Parsons delivers engineering and procurement, construction management services to the resources and energy sector. Inside Worley Parsons, the last few years, there's a group called Digital Enterprise, and they are tasked with the innovative leverage of technology to help internally our delivery and also our external partners with really maximising, getting a yield from their data for the asset lifecycle data management. And I guess I got to ask myself every day, why do I go to work? Why are we here? Engineers, constructors, project systems experts. We're here to save the world. Or maybe let's get it down a little bit. Maybe we're here to save our industry, or not so much our industry, but construction has been elusive in resource. The success of construction in the resources and energy sector, it's had a bit of a bad rap. There's been some poor performance. Productivity is the main issue. You guys may have seen these statistics before. 65% of projects failed. Failure constitutes, and this is major projects that are over $2 billion, constitutes either 25% cost overrun or schedule overrun, and most of it's down to productivity. And the productivity killers, I think, are waste. Time wasting, people, either waiting on engineering drawings, waiting on materials that haven't arrived, waiting on construction equipment, cranes, that type of planning has not gone exactly the way we want it. So we really want to increase our visibility and our predictability on projects. So as a construction and completion systems manager, I think someone else said it earlier, you sit in your ivory tower and you think, I'm going to develop this capability for the projects to leverage. At the end of the day, do I come to work to deliver technology to projects? Ultimately, I need to come to work to optimise project delivery. You can bear it all, you can strip it all back, but you've got to optimise project delivery. And so we do that. It's not leverage of innovation, it's leveraging technology in an innovative way to gain a competitive advantage. We want to, by having increased visibility and increased predictability, We can manage performance. We can see projects in a or performance in a multi-dimensional aspect. We can see how areas are performing, how disciplines are performing, how contractors are performing, how we're performing in relation to chasing after commissioning and completions. So I think about how do I apply technology to do this? So I exploit technology enablers. And so I just thought of it in a really simple way a couple of years ago. I said the three really simple ways of looking at this is the capitalising on data-centric delivery. So ensuring that upstream in the delivery process, we've got rich data. We've got, the model is rich, but it's not only engineering data, it's construction-ready engineering data. It's so that we don't have to retrospectively change data structures to allow for construction and materials management and commissioning data. It's exploiting the 3D model to get 4D, 5D, or multi-status visualizations so that we can foresee our opportunities and our constraints. And it's field computing technologies. I just kept it really simple, and I said, across these elements of construction, where can I apply one or all three of these? And these can either work independently across your initial definition of your scope, your contracting strategy, right through executions and inspections. They can work and deliver a yield to your performance independently, or they work collectively to give you, good data, gives you better visualization, and better visualization on field computing technologies gives you information to the field much quicker, and it allows you to get real-time status from the field much quicker, so you can have a proactive reaction. So, and that's all well, basically, sitting up in my ivory tower, but none of this works unless the people on the projects can use it. And you can develop a capability at a corporate level, and it's a round peg in a square hole because you need the people on projects to help you. And that's where I met Daniel. We have a bit of a collaboration forum in Worley Parsons. We've got the construction fraternity. We've got a one page that is a little bit like an internal LinkedIn. I think I posted something up there around the importance of completions and who should own completions in the delivery cycle. Is it the contractor, the owner, the PMC? He reached out to me, told me some really good things that he was doing with Navisworks, but said, hey, you're the global construction systems guy. I'd really like to digitise some processes here so I can get more data. I'd met the Autodesk guys, and we'd actually implemented field back in the Vela days out on the QGC project in Queensland. And that didn't really go that well, and that's because we didn't think about those three enabling factors of people, systems, and process. So we had this chance meeting. Daniel was showing us what he had done. Autodesk was showing us some capability around field. Daniel says, well, I don't need that, or that, but I need that. Can we make it happen? We're part of an Autodesk EPA, and we get some consulting credits, and that was a critical success factor in us being able to mobilise a solution to Southeast Asia under our consulting credits program. Basically, everything flew under the radar. We didn't really have to go through a whole approval cycle. We just got the job done. The case study that Daniel's going to show you goes into real detail. It's a retrofit solution. I guess a digital enterprise, what we're looking to do is we're looking to make this a scalable, repeatable, portable solution for not only hydrocarbons, but in the mining sector as well. And I guess we hope that this this transcends, BIM transcends further into, asset management and predictive analysis. A surety of the physical asset can be definitely delivered with some clarity in the digital asset. So Daniel is a unique individual, I think. I deal with people from all over the world, and we were talking about generational aspects this morning. Daniel, at 21, has been on oil and gas projects for the last 15 years, well, from 21 to now. I had a few beers with him the other night, started to work out why Daniel is like what he is. He is Yoda, Obi-Wan Kenobi, and Luke Skywalker all in one. He's had some great baby boomer mentors. Guys that commissioned the Ark has basically been his mentors. He comes equipped with Gen Y on the keyboard. He understands data. He's a Rain Man. And what we've got is we've got a bloke who understands construction delivery. He understands the critical path. He understands the old school baby boomer. This has got to what you got to touch it. You got to touch it. But he comes kitted out. I just say he's a good bit of kit. So let's have a look at the story. Thanks, Mark.
Absolutely no pressure, right? So I see myself as a workplace planning specialist. So what that really entails is being in the planning world, being able to bridge the gap into construction. So a lot of that is how you can apply technology, visibility, predictability, and ultimately give the people in the field what they need and when they need it. So the Hebron project was a 41,000-ton oil platform built in Southeast Asia. Tom pointed to this being retrofitted. So I joined the project 10 months into construction. We very quickly got Navisworks up and running, created a model-rich environment where we embedded data. We used contractor status to see visibility. So our foundations were strong, but we still ended up in a situation that wasn't particularly good. And then we were lucky enough to implement Bim360, and everything changed. So I'll say a very quick thank you to Andrew Hannell and Guy Penfold for the persistence and listening to me and, really delivering on everything we actually needed. So I'll start with a quote from Bill Gates. The first rule of any technology used in business is when you apply automation to an efficient process, you will magnify the efficiency. And counter to that, if it's an inefficient process, you will magnify the inefficiency. So the key to all of this isn't just throwing a technology at something and expecting an outcome. You must have a process, an understanding of why and how before you decide what you're going to do and how you're going to exploit it. So I'll look first, the presentation is in three real parts. First is process, high level, why it's important. The second will be showing how we were set up in a data-rich environment. And thirdly will be the application of Bim360 and outcomes. So improving construction performance, what do I mean by that? I believe in a completions-driven process, understanding the back end and what's important and driving that as early as possible. So from a completions-driven approach, there are three pillars that I believe in improving construction performance. First is safety. When you can bring completions activities further forward in the life cycle, you have the ability to reduce the back-end burden of people where the most dangerous activities tend to happen. Second, quality. When you have a progressive inspection process where you're looking at things much earlier, you have the ability to change behavior. And someone once said to me, quality should be built and not retrofitted. And third, schedule. You need to create a schedule certainty, and when you bring the completions process earlier and you maximize the benefits of the first two, you will naturally improve your cost position. So the objective, this is some sociological factors. A large part of this process that we implemented was met with huge resistance internally, from the client, from the contractor. It's never been done before, it won't work, I don't want to listen to it. So a lot of it is sociological. So what's the objective of this? It's removing complication from complexity. So the project we worked on in Hebron was highly complex. Multi-location, across cultures, multiple stakeholders, multiple systems, but complication actually comes from people. It's people not being aligned to a strategy, not understanding the processes, not following procedures, thinking they're doing the right thing, but working outside of what the bigger plan is. So we need to remove the complication. To do that, you need to create alignment. So that's alignment to strategy, to process, procedure, to technology. And when you do that, you create visibility. The creation of visibility is all about removing excuses to drive accountability. If you're going to demand accountability of your people, you need to empower them. This is then a change in mindset from what I can do to what I can't do. So to do that, it's about getting the right information to the right people in the right time frame, in the right formats, to support them being better. So this is about the alignment of three things, as Tom said: people, process, and technology. And when you do this well, you create the opportunity for enablement. We want people to influence outcomes. And when everyone can influence an outcome, you have a high-performing team. And a simple provision in construction: do it once, do it right, finish what you start. So the process overview, how we were set up on Hebron. So there's a construction management system that we developed, and this was linked through Navisworks Manage. So the great thing about the 3D model is it allows three things: visualization, understand; rationalization, improve; realization, execution. So the two of these, are effectively one thing. So this is loaded with a huge amount of information. So we want to take engineering data, the statuses, we want to understand rules of credit because that might drive behavior of the contractor. Completions data: if you don't have subsystemization, test pack development, tag allocation early in the life cycle, you cannot apply a completions-driven approach. You want to understand the contract schedule and also the contractor work packs. How are they thinking about executing? And as I said, I joined the project 10 months in, so a lot of this wasn't necessarily available. So we take all of this, and what we want to do is have a process where we can plan, execute, measure, and improve. It's a continuous process throughout the life cycle. It's around coordination, validation, analysis, and enabling decision-making. We go to a very granular level of detail. This is material availability, it's engineering status. We look at things like schedule optimization, and we look at the change management process. When we get this right, we can influence outcomes. And what it leads to is controlled delivery, early identification of opportunities, constraints, risks, vulnerabilities. We improve the management of change process because our engineers can see visibly in the model the status of things and come up with changes that minimize the impact to construction. Ultimately, what you want is a discrete transition to MC. The mechanical completion process is one of the things I think is most misunderstood in the industry. Everybody tends to jump on a bandwagon that we now need to completely change our approach. It's not. You just need to focus on different things. And finally, commercial protection. Lots of big oil and gas projects that I've worked on have ended up in a claim situation at the back end of projects. And one of the things, particularly for owners and EPCMs, if you have your own validated information throughout a construction cycle, you have the ability to commercially protect yourself. While it's an execution-driven focus, this is a byproduct. So a completions-driven process, why is this important? So if we look at a typical S-curve on a construction cycle, there are two key phases that most people see. There is bulk construction, and then there's this process that I call the completions process, typically happening after about 65%. What's interesting, statistics in Korea show that the last 25% of construction takes up to 50% of the overall duration. The last 10% can take up to 25% of the overall duration. So why is this? Bulk construction is relatively easy. Structural steel is their bread and butter. Bulk fabrication of spools and installation is easy. Counter to that, completions, it needs an attention to detail. You often had discovery rework. Man hours are often underestimated, which is all a byproduct of leading to the tail that is experienced on a lot of projects. So what we want to do is bring the completions process forward. And in doing that, you create the opportunity to reduce schedule or at least create predictability. So when we capitalize on completions opportunities early, there is the potential, in my opinion, to reduce schedules by up to 20%. So what is it we're actually looking at doing? So if we look at the key high-level activities during a construction cycle, structural steel, pipe fab, etc., all the way through to commissioning, what we're trying to do is identify discovery work sooner. This is something that hurts every single project. So in doing that, when you're doing progressive inspection, you're identifying opportunities, you can actually capitalize on the ability to test earlier, pull cables earlier, paint, go through the MC process earlier, and all of this supports reducing the back-end burden of people, which also will help improve safety. So how is it we're actually trying to do this? When we look at the typical sequence of activities for piping, we go through pipe fab, pipe install, we get to isometric completion, we want to then do test pack walkdowns when the test packs are available, testing, reinstatement, etc. A number that has been said to me throughout my whole career that I've never believed in is that 65% of spool install, we will start testing. I have asked so many people why. I've worked with great mentors who, are the grizzly bears of the industry, and Daniel, don't ask stupid questions. That one is just when we do it. So I've always been trying to develop a way where we can identify the opportunity to do these activities sooner. So how do we do that? What we want to be doing is looking at information differently and measuring the lags between each of these interface points. They might be interfaces between different contractors or interfaces between discrete activities. When you can shorten the lag between each of these, you'll naturally improve your schedule certainty. It's exactly the same for E&I. You go through the process of installing equipment inside rooms. You need to put your tray infrastructure in place to support cable pull. You put your devices in to terminate, and we get into our loop checks and enabling the commissioning process. Again, I've always been told it's about 65% complete of tray install. We'll start pulling cable. I'll show you why we don't need to do that. There are smarter ways with the tools available to enable this process much sooner. So opportunity and constraint analysis is something I've mentioned, so I'll just explain a bit further what I mean. So an opportunity is a set of circumstances that makes it possible to do something. So in our case, it was about either moving to the next stage or supporting another group to be successful in parallel. Counter to this, a constraint is a limitation or restriction. So there are three phases of an opportunity or a constraint, and you can use automation to identify these. So when you apply it to your process, for us, completions-driven approach, there are three things: identification, communication, and action. Now, the most important one is identification. If you don't identify it, it doesn't exist. If you can identify it, you can change the way you communicate. We can communicate things in 10 different formats to 10 different people if that's how they want it. And once it's communicated, management can enforce the need for action. And you can measure the action. And when you get this process in place, it's just a simple repeat, repeat, repeat. And it creates the predictability. So completions management. So here's a piping example of why you don't need to wait to 65% complete from the Hebron project. And you'll see that we didn't get into this process early enough. And I'll return to a safety example at the end to say why we should have been better. So back in January of last year, we were 28% spool install on the job. And what this graphic represents is 233 test packs that the subcontractor had reported all the spools were installed. So to me, there's an opportunity at 28% spool installed to get out and walk these packs down, get them through the QC process, and start early testing. Learn how many can we do at a given time. We provided information, detailed reports that broke down what the test pack were, the different types, the groupings. And if you look in the top right-hand corner, you'll see some of these packs have been available with the Delta column for 107 days. So there was an opportunity significantly earlier than this to capitalize. This information from our client, it was viewed that this was a contractor's responsibility. So we provided the information to the contractor and we asked them nicely, please, can you go and walk it down? Nothing happened. So we fast forward 14, 15 weeks. So now at the beginning of May, with 50% spool install, this graphic now represents 450 test packs that were available using contractor information to go and walk down. We'd in fact punched 90, but these were all 1 and 2 spool visual drain lines, which didn't really matter to anybody. So after producing these visuals and chasing the contractor for 3 or 4 months, our management actually made some decisions that we will take ownership for this. And we brought a team of 6 or 7 guys with a specific focus of going and walking these test packs down. So 6 weeks later, these guys have done a great job. Everything that's reflected here in orange, we had walked down. We're now at that magic number, 64% of spool installs, we're bound to start testing. So of the 586 test packs that are reflective here, we'd actually punched 352. So, well done to those guys. What was very interesting to me, of the 352, 118 of them are what they call Category A cleared. So they're hot work complete, they only need to go through a QC cycle, and we can test them. We only had 23 of these that were physically released for test. So while we had reduced a backlog in chasing these packs at a later stage than I would have advised, we had in fact created another problem for ourselves. The QC department was now so overloaded that they couldn't possibly catch up with the NDE requirements to turn these, then constraints into the opportunity. So I'll come back to this in an example at the end, but this was something, in my opinion, that we didn't do very well. So I've introduced the process, shown a little bit about what a completions-driven approach means to me. Now I'm going to show a bit of the part the 3D model played and how we were set up from a data-centric perspective. So, as I said earlier, the 3D model was enabled by our construction management system. So you literally can visualize and analyze anything you can create a relationship to, And any of the attribute data you then hold outside associated with that, you can pull into the model. So it can't plan, it can't execute, and it can't make decisions, but it can significantly improve the planning, execution, and decision-making process if you know how to use it. So we link our construction management system through Navisworks, which was an SQL link, thanks to Andrew Hannell, who helped massively there. And we then end up with what I call a supercharged model. It's not a BIM model, it didn't have documents linked to it or anything like that, but it was a supercharged model for construction application. So a number of examples of what we could do with it. So throughout the whole life cycle, we could visualize every single discipline, status, and we could break that down by subsystem areas and any of the other attributes. From a piping opportunity, we could visualize where we could go and walk test packs down, which ones had we walked down, which ones did we have problems with. We could look at what are all the isometrics with just one spool outstanding, or all the test packs with one spool outstanding, and color code the status. So the graphic on the right tells me everything that is orange, the spool was already in place. It just needed welding or flange management. This is easy opportunities for the contractors to go and get. The work's there for you. And we could prioritize these into a sequence that would deliver and optimize the commissioning sequence. From an insulation point of view, I was challenged partway through the job saying, you know, we've done all this great testing now already, but the insulation contractor for heat tracing and insulation doesn't have any work fronts. Really? Everything here in yellow had been reinstated already, which is the trigger point to say you can go and heat trace and insulate. This equated to 239 packs. Who said they don't have work scope? So very quickly, management can see a visual, can go and sit down and challenge a fabricator and say, look, you do have work scope, and this is exactly where it is. And this is the order we would like you to do it in. From a E&I point of view, which we'll get heavily into in the Bim360 example, you know, we looked at overall status. We could look at, you know, different punch levels, which were all configured through Bim360, tray not bolted, things that needed paints and supports. And we could look at things from a priority check point of view, whereby we didn't believe the tray was installed, but the contractor reported they'd pulled cables that I knew went through that tray infrastructure. So you could very quickly see, is there an over-report, or is there a problem that they're pulling cables that aren't even in tray? So from an E&I opportunity on our drilling equipment set, we could break the model down for tray infrastructure to say, what is all the tray infrastructure associated with a given room? This was the local equipment room. At the same moment in time, where can we pull cables? We can pull cables in all of these trays, and we can give a list of what those cables are. We could look at it from a whole facility. Why aren't we pulling cable? You have an opportunity to pull cable in all of these, and we can group that cable together for you to make it more efficient. And finally, we can look at E&I from a subsystem point of view, which is something that probably Autodesk don't promote. I know none of the other software vendors promote. And this can only be done through a data-centric approach and linking this information back into the model. So we go down to an even further level of detail. Here's just an example of an individual cable and its route where it goes. And here we can see there are 14 or 15 cables running exactly the same tray infrastructure. The tray's in. If you're going to pull one, pull all. Improved productivity. From an E&I perspective of devices, we had 18,000 end devices, panels, you know, beacons, lights, etc., a huge number. So we could see the status of all of these end devices. And what we were really trying to do here was drive through to open up termination availability, particularly in panels that had large volumes of cable. You want to get in, gland and terminate once, preserve the cabinet so you don't have issues as you get into commissioning. And a lot of this as well was focused on the completion of E&I rooms, which I'll touch on. Finally, from a subsystem point of view, this is a GTG package. You can see on the right the main GTG. Everything there that's in green, big, thick and bold is all the tray infrastructure associated with that subsystem. The things that are circled are junction boxes, field panels, vendor junction boxes, and on top the orange and the green items are pipe. So we could have multi-discipline subsystem views. We knew what we needed to chase down, and it also helped in the orientation when you do a subsystem walk down. So we've now touched on the fact that we had a data-centric setup. We had lots of visibility. The biggest problem now in getting people bought in was we don't believe the numbers. Some people thought the contractor was over-reporting. Some thought they were under-reporting. There was lots of arguments internally, so who knew what? So the whole drive now was around progressive inspection. You had seen that in May we had started it with piping. So what is progressive inspection? It's field status capture independent from what the contractor reports. And what's key behind this? Verified data, channeled correctly, creates the ability to influence outcomes. If you have incorrect data making fantastic decisions, your decision is ultimately going to be wrong or not optimized. So the foundation blocks of this is you need to know where you are, then analyze it correctly and enable and empower your management team. When you do this, what we've actually focused on is driving or changing contractor behavior. When you do that, you're doing it in such a way that you're not policing. you're actually trying to demonstrate to them that they can be more productive and more efficient. And when they are more productive and more efficient, you get the net results that you're looking from a performance point of view on the project. So the case study. So it was in around June of 2015 where we looked to implement Bim360. And this was really the turning point for the project. So now we'll go through it. So you've seen in the beginning introduction of this that we had a data-centric approach. We already applied opportunity and constraint analysis based on contractor reported status. We had full model visualization. So now progressive inspection was something that we needed to drive the outcomes that we were looking for. So this was where we applied Bim360 Field and Glue. And closely in this, we had a much closer collaboration with the fabricator than I think our client was ever used to or potentially comfortable with, but it ultimately drove the outcomes. So here's a graphic of the facility. But what we were focused on from progressive inspection was the E&I campaign. We knew that that was our critical path. So what did the E&I campaign look like? We had 9 major rooms. Those were all critical in sequence to delivering the commissioning sequence we needed. We had 85,000 meters of cable tray, 1.1 million meters of cable. To put that into perspective, that's like in a straight line going from here to Melbourne and back to Canberra. And this was all intricate throughout the facility. We had 18,000 panel and devices, 45,000 terminations. Obviously, each cable needs to be terminated at both ends. Some were left coiled. 26,000 check sheets and 9,000 instrument loops from a static commissioning point of view. And then we ended up rolling this into leak testing. So I'll just go through the process of how we co-joined Bim360 Field and Glue. So one of my key requirements at the beginning when I met with Rory, there's lots of good things, and you've seen in all the presentations today, I was in the Bim360 one this morning, that it can do a lot of great things. I was very, very specific in saying, that's great, but we don't need it. That's great, we don't need it. We wanted to focus on one thing, and that was field capture. So that was how we configured. Secondly, there was lots of talk on the project about it can't be done. So in order for me to be successful in implementing this, we had to go very narrow. We focused just on cable tray. I wanted to prove concept and expand very, very quickly if the need required. So our engineering model was developed in Aviva, so we needed a process of conversion, which was fairly easy for Navisworks. The key inputs on the left are the same things that you've seen at the beginning. And we pulled this into our SQL database with the purpose here of supercharging the Navisworks model. So Aviva into our VM files, into Navisworks. So the Navisworks to the database process is a push and pull. You want to pull from the model to make sure everything is captured, and you want to push and embed further information in. And it was this embedding process that enabled us to create the selection sets that enabled Bim360 Field to work in the way that it did. So Navisworks on the desktop then ties through the collaboration of Bim360 Glue and Field, and it's this that then enables the iPads to be used in the field. So the latest revision of the model we could continually load. We could pull the daily sync status down, which was twice daily, back into our database. So everything here in pink was done in the Autodesk environment. We would then push and pull information into the Bim360 world. Go and check these things for us because they're a priority, or the contractor says they're in, and pull the information down that we were validating. So all of this was then continually analysed, which was then the driver of our opportunity and constraint analysis. And ultimately, you get a number of outputs. You get visualizations, which is great, but most important to me was the data. I wanted to be able to do something with that data to drive outcomes. So what was our cable tray problem? The contractor only reported a linear meterage of tray. So all tray in a model, or in our model, has an individual number. So ultimately, you want them to report against this tray A is installed or tray A is half installed. What drove us to the realization we had a really big problem, where they didn't report on any branches, they started to. And I would get a report that said on week 1, branch A, we've installed 14 meters. And on week 2, we had installed another 10 meters of branch A. And on week 3, we'd installed another 10 meters. Something didn't look right to me. So I just did a simple off-take from the model. And I worked out that branch A was actually only 13 meters long. So how can a contractor who's reporting a linear meterage have installed 30-something meters of the same piece of tray that I know was only 13 meters long? So we had a problem. So the contractor was reporting we were 65% installed, but we hadn't started pulling cable. So we needed to understand why. So this was when we wanted to put the progressive inspection process in around cable tray to get line of sight. In parallel to this, the next challenge was going to be, what are the cable pulling figures that we can achieve on the project to deliver outcomes? So projects of similar size and scale to the one we were delivering, the yard norm was 22,000 meters a week of consistent cable pull. If we had been left with 22,000 meters of cable pull, I would not be here today. I would still be in Korea, and I would still be in Korea, most likely there for Christmas. At a stretch target, if we provided an enabler of more people, they believe they could go to 36,000 meters a week. 36,000 meters a week that we sensed they were not confident about. That would have left us with probably a sail away of about the 10th of October this year. What we knew we needed was in excess of 50,000 meters a week. So how are we going to go about doing that? So let's go back to the process. We had a very good handle on the install of equipment inside of rooms. They're big panels, they're easy to see, you can go and touch them. What we didn't have line of sight on was the supports and the tray infrastructure. That was obvious that we hadn't started pulling cable. We then also needed line of sight on end devices so we can enable terminations and drive the commissioning sequence. So first off was line of sight. We had to get this on cable tray. Once we had it, our data-centric approach would enable us to identify which cables could be pulled, how they could be grouped to optimize the efficiency. And finally, collective action, a hell of a lot of hard work, and repeat the process. So much to my annoyance, while we did start a progressive inspection process, the company chose to do it manually. So we used something called nodal drawings. So nodal drawings are cable routing drawings, which actually meant 85% of the tray has a nodal reference, the other 15% doesn't. So we were never going to get to 100%. It was actually quite difficult to locate the scope with these drawings. As you can see on the right-hand side, we had about 7 different punch categories we wanted to capture. So these guys had 7 different colored highlighters. When it was raining, it wasn't particularly friendly for them to go across drawings, as you could see. They then had to return to the office, do an off-take of these nodal drawings, put it into an Excel spreadsheet. I had to run a conversion to turn node points back into tray branches, and all of this took time. So in 55 days of applying a manual process, we validated 4,738 meters of complete branches were punch clear installed. And on average, it took between 3 and 5 days to get that information from capture for the ability for us to use it. So what was very clear to me after 25 days that we either needed to go from 8 or 10 people doing manual inspections to 50 to play catch up, or we were never going to get line of sight. And I pushed back again and said, can we please just give Bim360 a try? The resistance at first was, there's no money to pay for it. Tom and Autodesk and the credits resolved that to the project, it's free. It will never work. It's never been done before. Please just give me a chance. I need 7 days to prove that this can work. And we got that. And Guy came out, we spent 4 very, very late nights making it work, making it work. And this was the outcomes. So we had the model on the iPad. What this enabled, and it was the latest revision. So we didn't have to go through every morning, are we using the latest drawings? I could upload the latest model for the guys to use. Using a model on an iPad means orientation is so much quicker and easier. You can get out and locate what you're looking for much quicker. It enabled continuation. You're not flicking through drawings, you're just following a model. It was easy to update. We had a standard set of capture of things we were capturing, so we had consistency of data. In just 11 days, we captured a further 5,957 meters of completely installed tray. This was 25% more in a fifth of the time. This enabled us to play catch-up. This equated to a 630% efficiency in capture, and our data availability was anywhere between 300% and 500% because we were syncing on a twice daily basis. Within about a further 10 days of this, we had confidence that we had validated pretty much the full facility. That's a good thing. The scary thing was we actually only had about 15% versus 75% of punch clear tray that we could pull cables in. We had a problem. What did we do about it? So the achievement of record cable pull came down to a number of factors. Because of the granular level of punch status we were able to capture, things like this graphic were trays that were installed that were just missing bolts. So get out there with all the lower tier subcontractors, walk with them, and just put the bolts in. So low-hanging fruit gave us numbers very, very quickly. Our data-centric approach means we knew every single cable that ran in which tray. So this graphic here just represents like a heat map of trays that carry the largest volumes of cable. Because we had all subsystemization and the priorities in the model, we could very quickly say, this is the tray we want you to install, and this is why. And then there was a lot of hard work. So we very quickly got to a stage we were installing punch clear tray of about 3,500 meters a week. Because we had accurate tray status available, it meant we could identify the cable pool that was available. It could be grouped to increase the productivity. 14-week average was 54,000 meters. These are numbers that the yard had never ever seen, more than double what they thought was even possible. And this created the foundation blocks for success. Our record week was just under 74,000 meters of cable pull. Quite incredible numbers. So I'll backtrack now about another 8 or 10 weeks. So after the initial success of cable tray, where else can we apply this? So end devices. This is the next stage after you get into pulling cables. The difference with end devices, they had actually reported what devices were installed. So here are reflected red. This meant our guys inspecting could go out and chase the things down that are red. There's a higher probability that we're going to find that it's installed. Not only did we want to capture that the device was installed, but through the data-centric approach, we could embed further information in Bim360 and say, while you're at something, checking this bottle of water, also tell me, has it got its label on it, has it got its lid on it, and is it half full? So the other things we were capturing, this individual device should have 4 cables at it. The contractor says there are 4. How many are glanded? How many are terminated? So we've got a very granular level of detail without wasting the guys' time doing the physical inspections. What all of this was driven towards was the termination availability. A panel that has 20 cables, all of them are there. Get in, do it once, shut it up, preserve. What was interesting in this particular outcomes, it wasn't that the contractor was over-reporting. They were in fact massively under-reporting in so many cases. And when you're trying to chase completions, under-reporting is just as bad as over-reporting. While I have worked in the project controls world, I'm much more execution focused. And I'm more interested in the numbers, and when they're finished, it's good. So how do we then take the data post-terminations? So the terminations drove the ability to do mega checks on the cables, which then in turn enabled us to sign check sheets. We then built the relationship to say we have a panel, it has a power cable, it feeds a junction box, it has an instrument cable that feeds a device. And we knew the status through using our MC system, the data from Bim360, to say when all of these triggers go off, you can go and shoot that loop. What we were able to do was achieve 4,500 of our 9,000 loops pre-MC. I believe that these will be industry-leading numbers. It just doesn't happen. And we went one step further into the dynamic commissioning to say, now we have all this loop information, what are the loops associated with cause and effects, and can we get after these earlier from a dynamic commissioning? So what we had done is gone from a situation where we were effectively blind on E&I scope, other than the panels in the rooms. We'd created clear visibility throughout the process, and we were able to drive performance all the way through to cause and effects. We had a final problem towards the end where our leak testing crews were up against it. We had lost a bit of focus on piping, and the number of times people came to me saying, Daniel, we can't find this valve, can you show me in the model where it is? So very quickly we just configured the iPads and said, have it with you in the field. Here's one loop, here's one leak test. So what we did to make it easier, all the valves are red, all the flanges are green. It helped with orientation, but also from a safety point of view as setup. What we wanted them to do, you have to tape and tag and isolate all the relevant points. So from a safety setup, we knew that we were good to go. And we could also capture which are the leak points. What we were able to do in the first 3 leak tests was identify we had a problem with autoclave fittings. So what we would do is we would get ahead of time and all the other leak packs that had autoclave fittings and do a double check on them to reduce the number of leaks we were experiencing later. So what was the benefit summary? We had up to 630% efficiency on cable tray inspection. We were able to increase the inspectors' times in the field by around 2 hours. Data availability, significant improvements. We had accuracy, the tray example 15 versus 70. We had a productivity improvement against the yard norm of 250%, record week 350%. We don't have metrics for end devices, but the end devices drove terminations, which improved the metrics for completion of loops. And from a leak test point of view, we were able to create the efficiency and walk down by 200%, and the numbers of how many potential leaks we stopped, we don't have, but we know it was a vast improvement. So the project benefits summary. What we had actually done just from a process point of view was created status visibility that was accurate. We identified and visualized opportunities that enabled cross-cultures in a Korean yard to be very quickly understood. We enabled the open communication. We got away from the fluff and the noise of what is, what isn't. We had truth. And what we did, we empowered not only our team, but the contractors' team to drive the right outcomes. And what we ended up doing was realizing a sail away of the 28th of June this year, which was incredible. And what that ends up doing is leaving the project's real target, which is first oil in 2017, a real reality. What this ended up doing, I'm the planner on the job, so I knew where the forecasts were going. And as I had said to you, if it was 22,000 meters a week, I'd have been there till Christmas. We can prove that this process alone in the last 12 months saved 3 months on the schedule. And just on our PMT costs in Korea alone, that's about $50 million. let alone all the other enablers and things you would have had to have paid a contractor to chase and finish at the back end. So the numbers are fantastic. While all of that's good, I want to bring it back to reality and back to safety. So this is the projection of the job as of February last year. And the histogram underneath is a reflection on the number of people. And that was roughly our forecast to go at the time. So as you can see here, our completions process didn't take 50% of the time. But you can also see it was measured with a significant increase in people, around double. During the project, we had 4 near misses, or high potentials of a serious safety incident. These are all highlighted here in yellow. And we had 1 LTI where we hurt somebody quite badly. Luckily, he's made a full recovery. It was a clamp came off under pressure on a hydro test. What's interesting, we had a sister project in the yard. They had 1 LTI associated with testing, and it happened right near the end. On the drilling equipment set, we had 1 high potential related to store energy in E&I commissioning, again, right near the back end. There were other projects in the yard, some other very big projects. Some of them had gone 600 days, 15 million man-hours without an LTI, and then had a spattering of 3 or 4 right at the very end. And in my 2 years in the yard, there were 3 fatalities. Not on my projects, but all of them happened at the back end. What I'm trying to point to here is there a systemic cause that we increase the probability of hurting people at the back end because we fail to focus on some of these activities sooner. And that gets counterbalanced by throwing people at the job at the back end because you're schedule constrained and everybody's trying to drive an outcome. So while I don't have details on all the other projects, I will focus on our testing example. So the black curve here represents what happened to us from our testing. What we were left with is, as you see in August when we really started to ramp up, that was also matched with a ramp up of people. What we achieved was 250 tests per month consistently across a 7-month period. So that's fantastic performance. You know, in line with this though, we needed to test before we could reinstate, and we need to reinstate before we can heat trace and insulate. So you get the idea here that there was a big backup of work that was going to follow this. As I showed in the testing example earlier in the visuals, we had opportunity to be after some of this much, much sooner. So this orange curve is reflective of when the packs were available for us to go and walk them down. And if you assume that a large number of them were good to go, but if we allow a 4-week period from identification to walk down through QC, setup and test, we had the ability to be 33% further advanced at that August date. That would have led to only 1,200 tests to go over 7 months, maybe only 1,300 reinstatements, maybe only 600 to heat trace and reinstate. I don't know what the outcome would have been, but I'm pretty sure that we wouldn't have needed that many people. We wouldn't have been under that much schedule pressure because we would have been further advanced, and maybe that guy wouldn't have got hurt. So while the performance outcomes were good, this just highlights that we can be better. So in summary, what I've talked about is a completions-focused approach and strategy, enabled through progressive inspection, enables you to drive and influence contractor behavior. When you empower your team with the right information in the right formats, you combine that with visualization, it makes it visible for everyone, top to bottom. What this does is drive accountability. And when you have an accountable workforce capitalizing on completions opportunities, you have the ability to improve project performance. It also has the opportunity to improve safety, improve quality, improve schedule certainty, and client satisfaction. I've got one last slide and I'm on time. I will finish with an anecdotal story, very tongue-in-cheek, and hopefully it'll be refreshing as we finish. So guy meets girl. They have a few drinks, they decide they like each other. They go on a few dates and everything looks rosy. After a period of time, they make a commitment to one another, and soon after, they're married. For their honeymoon, they decide to go on a road trip. So they get themselves loaded up in the car, armed with good intent and all the nice places they're going to see. With their map, they set off. Partway into the journey, they realize they've taken the wrong turn. But anyway, they think that we'll use the map, we'll find our own way, and they carry on talking. A bit later, the wife says, I think we're going the wrong way. Maybe we should turn back. And the husband argues, well, haven't you been looking at the map? And she says, haven't you been paying attention? Anyway, some tension ensues, but it soon is apparent that arguments are coming, they end up lost and stranded, and that's not good for any married couple. You know, we live in the 21st century where this never had to be this way. They get married, they go on a road trip, and this time they're armed with a GPS system. While they go the wrong way, the GPS system brings them back on track. They arrive at their destination, and they live happily ever after. You see, while this is tongue-in-cheek, this is very similar to the industry in which I work. Large owner engages large engineering firm. They'd have some discussions about delivering a project together. They move into engineering armed with good intent, and this is going to be the best project ever. They move into construction armed with a 20,000 activity Primavera schedule, without failing to set their things up for success for their journey. Partway into the journey, they don't have the tools to recognize that they're going the wrong way or things aren't good enough. And it often ends up way too late in the delivery cycle until you suddenly realize you've got a big problem. Projects often end up stranded. It's not good for project outcomes, it's not good for stakeholders, and it's not good for the relationship of the two parties involved. It doesn't have to be that way. We live in a day and age, Autodesk products, GPS systems, where we can set up for construction better. There's stuff being done by FIATEC Construction Industry Institute in advanced work packaging and all those. That's great. That's all setting yourself up for construction. But it's the ability to react in real time, to visualize it, empower decision makers, have accurate information that will transform and change the way we deliver projects so that safe, on-time delivery is a reality. Thank you.